Hey everyone, welcome back. Today we're going to look at factoring polynomials of this form, x squared plus bx plus c. So the term in front of the x squared, the coefficient is a 1. And if you completed the previous polynomial videos in grade 10 and grade 9, today's lesson will be a lot easier for you. So at the end of the video, I'm going to explain the method a little bit, and I'm also going to discuss why we factor. I'll give you some examples. So let's dive right in. So here we have x minus 2 times x plus 3, and we've seen multiplication. We've seen that. You multiply x squared plus 3x minus 2x minus 6, collect like terms, so you get x squared plus x minus 6. Factoring is going in the opposite direction, where we're given a polynomial like this, and we want to factor to turn it into this form. So I'm going to do lots of examples. If you don't quite grasp after 1 or 2 examples, don't worry, stay with it, and I'm going to do lots and lots of examples. And then after, you'll have a lot of practice problems for you to practice your understanding. So example 1, factor. So here we have x squared plus x minus 6. And so what we're going to do is we're going to look at product 1 times negative 6 gives negative 6, like that. And then we're going to write s for sum to be the coefficient in front of the middle term, which is a 1, right? This is plus 1x, like that. So we're going to write a 1 here. And now what we want to do is find two numbers that when we multiply, we get negative 6. And so we could do 1 times negative 6, right? We could do that. But we also want the numbers to add up to 1. We want the sum to be 1. So we can't choose 1 and negative 6, because if we add it up, we get negative 5, and we want a 1. So we'll look at negative 2 and 3. Multiply that gives negative 6, and if we add that, we get a 1. So these are the correct two numbers that we want, minus 2 and 3. And this particular thing that we just did, you get better with practice. In the whole lesson, this might be the most difficult part. So some tips for you is to always look at the product first. You always want to get the factors of product, like 1 or 6, 2 or 3, stuff like that. Okay, so this is probably the most challenging part, but you will get better with practice. And so these two numbers that we found are the numbers that we use. So we have this polynomial equal to x minus 2, right? That's the minus 2 we got here, times x plus 3, right? There's a plus 3 there. And so those are the numbers that we use. And we're going to check it. We're going to multiply right now. X squared plus 3x minus 2x minus 6. Collect like terms, x squared plus x minus 6, which is what we want. So this is beautiful. So whenever you're doing your test, I highly recommend that you just do a quick little check on your answers and make sure that you did it properly. Now, you're going to notice in the examples that I'm doing 1 times negative 6. I'm going to do that all the time here. This next one, I'm going to do 1 times negative 4. That's what this little line here is, 1 times negative 4 product. And you might say, well, why are you doing that? It's always a 1. You don't need to do that. The reason is because later in grade 11, we're going to look at the product when a is not 1, right? It could be a 3, for example. And so the method in this type of polynomial is 3 times negative 1 as your product. So if we're doing this now just to get in that habit, it'll help you later in grade 11. Okay, so B. X squared minus 3x minus 4. So our product is 1 times negative 4, which is negative 4. And the sum is the second term, negative 3, like that. So we want to find two numbers that multiply to 4 and add up to negative 3. Right? So for example, you could go 2 and negative 2. But when you add that up, it goes to 0. It doesn't go to negative 3. So we say, okay, we'll look at 1 and 4. And we want the sum to be negative, so we'll put negative 4 plus 1 gives negative 3. So 1 times negative 4, 1 plus negative 4, negative 3. And so these are the two numbers that we use. So this polynomial is equal to x plus 1 times x minus 4, like that. And we're going to check our answer here. So we got x squared minus 4x plus x minus 4, collect like terms, x squared minus 3x minus 4, which is what it's supposed to be. Okay, more examples, lots of examples. So C, x squared plus 6x plus 8. So product is 8, sum is 6. So we're going to look at products for 8. It could be 1 and 8, 2 and 4. We notice that 2 plus 4 gives 6, 2 times 4 gives 8, so those are the two numbers. So this polynomial is equal to x plus 2 times x plus 4, like that. D, x squared minus 1. This is a special case that I'll talk about at the end of the video, but if you don't remember that it's a special case, you can still do it the long way, which is what we're going to do now. Multiply like this, negative 1, and it's a 0x. You see how I did that? X squared plus 0x minus 1. So the sum here is 0. So what gives negative 1? 1 times negative 1 does. So times that, we're good. Add that up, it gives 0. Perfect. So those are the two numbers that we use. X plus 1, x minus 1. E, x squared minus 5x minus 14. Product is negative 14. Sum is negative 5. What gives 14? 2 and 7. We want it to be negative, so one of them is negative, but we want the sum to be negative, so the negative 7 here plus 2 gives negative 5, like that. So we found our two numbers. We're going to use them, x plus 2, x minus 7, like that. F, x squared minus 20 minus x. So we want to rewrite that into descending order, x squared minus x minus 20, like that. Product minus 20, sum negative 1. So we're going to look at 4 times 5, that gives 20. So negative 5 plus 4 is negative 1. So these are the correct numbers. So x plus 4 times x minus 5, like that. Okay, more examples, lots of examples. G. So we got 3x squared plus 3x minus 36. So we saw in our common factor video, we got 3 in common. So we're going to factor that out. What's left is x squared plus x minus 12. And so now we're going to factor this polynomial right here, x squared plus x minus 12. We're going to factor that out right now. So our product is negative 12. Our sum is 1. We're looking at 3 and 4. So negative 3 times 4 gives negative 12. Add them up, we get 1. So these are the two numbers that we use. So this polynomial is equal to 3, right? The 3 remains, times x minus 3 and x plus 4, like that. H, x squared plus 3. So product of 3, sum of 0. And 3 is prime, so you can only go 1 times 3 or negative 1 times negative 3, like that. None of them add up to 0, so we have no solution. So x squared plus 3 cannot be factored any further. Okay, I. So this one's a little tricky, but it's still the same method. So here we have 1 times negative 6y squared, right? Like that. So we write that down, product, negative 6y squared. Negative y here is our sum, right? Notice that the negative y is the coefficient. So I rewrote it so that you'd see it, negative yx, like that. The negative y is the sum, that's the coefficient. So now we want a product of negative 6y squared. So to get y squared, we know it has to be y times y. That's the first part. And then now we say, okay, what about the number 6? Could be 1 and 6, 2 or 3. And we're going with 2 and 3 because we want the add up of the numbers to be 1. Right? So negative 3y plus 2y gives negative 1y, like that. And so we found the two numbers that go in there, go for our product here, our factor. So we're having x plus 2y times x minus 3y, like that. And if you check your answer, you will get this polynomial. J, product negative 4y squared, sum is 3y, like that, positive 3y. So we know it's y times y. To get 4, we could do 1 and 4 or 2 and 2, but we want a sum of 3. So we'll go 4 times negative 1 to get negative 4. 4 minus 1 gives 3, like that. So these are the numbers we use. So x minus y times x plus 4y, like that. Okay, time for some practice. This is where you get a lot of learning, so you got to practice on your own. So go ahead and pause the video and factor these polynomials. Okay, we're back. A, x squared times negative 3, that's our product. Sum is 2. 1 times 3 gives 3, and so we're putting the 1 negative, so 3 minus 1 is 2, so those are the two numbers. We use those two numbers, x minus 1 times x plus 3, like that. B, product is negative 8, sum is negative 2. 2 times 4 gives 8. 2 times negative 4 gives negative 8, and if we add them, it gives negative 2. So these are the two numbers, so it's x plus 2 times x minus 4. C, product of 20, sum of 9. 20 could be 2 times 10, 4 times 5. 4 times 5 add up to 9, so those are the numbers we use, x plus 4 times x plus 5. D, x squared minus 4, so we write that as x squared plus 0x minus 4. Product is negative 4, sum is 0. 2 and negative 2 are the two numbers, so we would go x plus 2, x minus 2, like that. E, product is negative 18, sum negative 3. 6 times 3 gives 18, so we'll put the 6 negative so that when we add them we get negative 3, like that. So these are the two numbers, so it's x minus 6 times x plus 3, like that. F, product of negative 32, sum of negative 4. We're going to look at 4 and 8 for 32, put the 8 negative so that when we sum we get negative 4, like that. And so these are the two numbers that we have, so x plus 4 times x minus 8. G, so we have a 2 as a common factor, so we factor that out. What's left is x squared minus x minus 6. Sum is negative 1, product is negative 6. 2 and negative 3 are the two numbers, right? Add up to negative 1, multiply to negative 6. These are the two numbers we use, so it's 2 times x plus 2 times x minus 3. H, x squared plus 5. X squared plus 0x plus 5, product of 5, sum of 0. 1 times 5 or negative 1 times negative 5, none of them work to add to 0, so x squared plus 5 cannot be factored any further. Okay, I, product is negative 6y squared, sum is y, like that. So product negative 6y squared, sum is y. We know that's going to be a y times y to get y squared. It could be 1 or 6, but we're looking to add up to 1, so we use 2 and 3. Negative 2 times 3 gives negative 6. Negative 2 plus 3 gives 1, so these are the two numbers. So x minus 2y times x plus 3y, like that. J, product 2y squared, sum is 3y. We know that it's y times y for the letters. 2 is 1 times 2, so we add that, gives 3y, so that's perfect. So these are the two numbers we use, so it's x plus y times x plus 2y, like that. Okay, special case. If we have x minus a times x plus a, this gives us x squared minus a squared. And this is called a difference of squares. So we're going to use the opposite of this, in the opposite direction. If we're given x squared minus 9, we can factor it quickly as x minus 3 times x plus 3, like that. So we're going to practice this a little bit because seeing a difference of squares makes factoring a lot easier. So x squared minus 25. So x minus 5 times x plus 5. X squared minus 144. X minus 12 times x plus 12. 4x squared minus y squared. So the square root here is 2x. Square root here is y. So 2x minus y times 2x plus y. 16x squared. Square root of that is 4x. Minus 25a squared, square root of that is 5a. So 4x minus 5a times 4x plus 5a, like that. Okay, so time for you to practice a little bit. Here we go. So practice number 2, factor these difference of squares. Go ahead and pause the video and answer that. Okay, we're back. So x minus 4, x plus 4, x minus 6, x plus 6. Square root is x, square root is 2. So x minus 2 times x plus 2. X minus y times x plus y. Here we have a 4 in common, so we factor out the 4 first. Now we have x squared minus 1, so this is just like x squared minus 1 squared. So this is x minus 1 times x plus 1, like that. X squared minus 1, that's the same thing, x minus 1 times x plus 1. 25x squared minus 49y squared, so square root of 25x squared is 5x. Square root of 49y squared is 7y. So 5x minus 7y times 5x plus 7y. Okay, so in case you're interested, the method that we just used, if we have it in factored form like this and we multiply, we get x squared plus mx plus mn, like that. And so if we're given a polynomial here, x squared plus bx plus c, this 1 times c will be a product of two numbers. So this 1 times c is going to be a product of two numbers. And the b here is going to be a sum of those same two numbers, m plus n. So we're looking for two numbers that multiply together gives c, and when they add together gives b, like that. Okay, so quick little comment here, why factor? So I'm just going to give you two little examples here. First example, we have a polynomial as a function, and sometimes we want to know when the polynomial is 0. And so we could guess, we could plug in 1. We get 1 squared plus 1 minus 6 gives negative 4. That's not 0. So we could guess a whole bunch of numbers. But if we factor x squared plus x minus 6 giving x minus 2 times x plus 3, so if this is equal to 0, finding the zeros are a lot easier now. Because if we plug in 2, we get 2 minus 2, which gives 0. And then this gives 5. 0 times 5 is 0. So we see that if we plug in 2 here, the whole thing becomes 0. And it's the same thing here with negative 3. If we plug in negative 3 here, negative 3 plus 3 gives 0. And 0 times negative 5 gives 0, like that. So when we have it factored, it's a lot easier to answer this question of when is the polynomial 0. Another example here is when we have rational functions like this. We factor the top here, and we have x minus 2 on the top and bottom. These cancel out with each other. What remains is x plus 3. And so this is used later in grade 11 and grade 12. And so that's it. It's that simple. I'll see you guys in the next video.